Hello, everyone. Can everyone see and hear me? Okay. We start. My name is Krzysztof Kochanowski. I am the CEO of Hydrogen Poland, and today I'm pleased to lead the debate on the hydrogen economy. I welcome all the participants of the discussion on the prospect of cooperation in the field of hydrogen economy between Poland and Great Britain. I especially greet the representative of the British government, Ms. Salisbury, and representative of the Polish government, Mr. Szymon Byliński. I also greet the representative of Polish and British business who will present their hydrogen project and areas for business cooperation between Poland and Great Britain during today's debate. Hello to all listeners too. The debate will last 1 hour, so I'm asking all speakers to keep time discipline. After the presentation, there will be a discussion, and here too I'm asking our experts for time discipline. Please do not be offended by how I will react in this matter. I also advise that other people should have the microphone turned off while speaking. Let's first listen to the presentation from Esperis. Mr. Łukasz Antas will explain the status of the Polish hydrogen market. Dear Łukasz, the platform is yours. Please.
Thank you very much. Can you hear me?
Yes, I hear you. Okay, yes, for me is perfect.
Excellent. Thank you for the invitation, and I'm waiting really for interesting discussion afterwards. But first, start with my presentation. So, short agenda. I will talk about hydrogen production and distribution projects. Then shortly about government strategy. Comparison with neighbors might be interesting for you, and short conclusions. Okay, here we go. The starting point, the Poland is one of the major gray hydrogen producer in Europe, about 1 million per year, pretty similar like UK. However, as far as I know, only maybe 600,000 tons are traded to be sold to other stakeholders. That's why all new projects like those on the right side are very important. The flagship is, of course, the hydrogen hub, which will be described later, I guess, by the Orlen representative. The others are like PGNiG, which is gas incumbent in Poland. It is really interested in both blue and green hydrogen project. ZEPAK, the third one, is a utility which is pivoting to hydrogen. The other utilities are discussing so far hydrogen issue. There is also a fourth project prepared by LOTOS currently in analysis. In case of demand, on the left side, right now, most of the projects are focused on public transport and refueling station. I expect it might be quite substantial demand for the hydrogen buses calculated, for example, by Orlen. And the refueling station project will be announced next year, I guess, as soon as the municipalities will start to purchase hydrogen buses. On the other hand, you have research on the right side. I mentioned here only the are also many smaller ones. What is worth to look is that the projects are led mostly by state-owned companies or state-controlled companies like LOTOS, Orlen, PEGNIC, PSE, or PKP railway operator, which is pretty important because otherwise, I guess, hydrogen economy will not be progressing in Poland. However, all those players are waiting for government strategy and what we have learned so far from government announcements. I hope we'll learn more from Mr. Byliński from Climate Ministry. What we can expect? Well, first of all, technology neutrality, which means gray hydrogen will not go away quickly. It will be replaced by green hydrogen with help of offshore wind projects, which is pretty important. And probably also by hydrogen from coal gasification with CCS installation. We'll see. It's quite crucial for coal industry here in Poland. In case of demand, government strategy will go very wide. I mean, energy, industry, transport, all of them are expected to be included in hydrogen economy, with help, of course, of public and private money. And previously, a state-controlled company should be on the front of the hydrogen economy here in Poland. And next year, we expect even several regulations either to be created or to be changed in Poland, which is pretty important. Details will be known next month. And I expect also some targets for refueling station prepared by government and some maybe in details, maybe general information that the joint cooperation with foreign entities is expected and needed. Maybe I will have the chance to speak about this later. However, we are not alone here in the region. As you know, everybody is talking about hydrogen and sometimes implementing the hydrogen. By the way, in November, we prepare a public report about those neighboring countries and the hydrogen, so I invite you to our website. What I would like to underline amongst those many projects is Ukraine, which is really keen on hydrogen. They were included in European hydrogen strategy as possible hydrogen producer and exporter, and they even tested so far the hydrogen injection in distribution gas pipeline. So it's very encouraging. And on the other side, I would like to underline the Czech Republic, the idea of hydrogen grid. They are part of the hydrogen backbone initiative, which plan to a long-term project, but you can imagine that the Ukrainian hydrogen and maybe the Russian one, who knows, will be transported via old gas pipeline through Slovakia and Czech Republic to Western Europe, or maybe through Poland, who knows, kind of the race right now here. And to conclude the short presentation, so short conclusion, we need to play the stable regulatory framework, and I hope it will be in place next year. Definitely we need funding, also from UK if it's possible. Venture capitals are welcome, but also public and private money here in Poland, and definitely funding. I think transport sector and the cooperation between Western Poland and Eastern Germany could be included in the transborder project. They are most probable section for this project. And it's important to have the funding to support the research in Poland. Research capacity in Poland is quite good, advanced in case of universities. However, I expect that in few fields like fuel cells and electrolysis, we definitely need the transfer of know-how from abroad. Otherwise, the progress in hydrogen economy will be very slow. And all of this should be also analyzed in the context of our situation. As you know, the fossil fuel dependence is quite strong in Poland. And what should be mentioned here is great dependence in petrochemical and chemical sector, which are main actually producer of gray hydrogen as well. And I hope during greening of the chemical and petrochemical sector, also technology in Poland be prepared and then exported worldwide, as the greening of those sectors is a major challenge. Okay, thank you for your attention. I invite you to our website, as we are not only concerned about hydrogen, but also specialized in other fields of energy. Thank you very much, and I give back the floor.
Okay, thank you, Łukasz. Now I invite you, Amy Salisbury from UK government. Amy is from Department for Business, Energy and Industrial Strategy, and she presents UK hydrogen activities and ambitions. Dear Amy, the platform is yours for 5 minutes.
Good afternoon, all. I hope you can all see and hear me. So as per the introduction, I'm going to say a few words today about the UK government perspective on the role of hydrogen in decarbonisation. So to start off, the UK is committed to decarbonisation. Over the past 3 decades, we've been a leader, cutting UK emissions by over 43% while growing our economy by 3/4. And we now have a legally binding commitment to achieve net zero emissions by 2050. And natural gas has played a really important role in supporting decarbonisation so far, moving us away from coal and providing flexible power generation to complement intermittent renewables. However, today, natural gas is associated with approximately 50% of the UK's carbon emissions. So we need to make big changes to reach our net zero ambition and eliminate the carbon emissions associated with natural gas. But this doesn't mean the UK should stop the use of natural gas, but it does mean being ambitious in the way that we use the carbon, we address the carbon emissions associated with it. So there are a number of options that allow us to eliminate or mitigate carbon emissions completely in the use of gas. And the UK is particularly excited about the potential of 2 things: carbon capture, use and storage, CCUS, and hydrogen, both of which are cornerstones of our net zero planning because they allow us to decarbonise both nationally and regionally while creating new, high-value, long-lasting jobs. So firstly, on CCUS, the UK is committed to deploying CCUS this decade and see an opportunity for the UK to become a global leader. CCUS will be important in the decarbonisation of industry, power and hydrogen and can support the development of negative emissions. The UK is also committed to developing hydrogen as a strategic decarbonised energy carrier. And between 2015 and 2021, we're investing up to 121 million in hydrogen innovation across the value chain, from production through to end use. And we're also developing new policy in partnership with industry to bring forward the technologies and supply chains we'll need to grow the UK economy. This includes developing business models to support the deployment of and investment in low carbon hydrogen production, and a £100 million low carbon hydrogen production fund to stimulate capital investment. And we're also aiming to publish a hydrogen strategy in early 2021. Setting out a clear strategic approach to hydrogen is essential, and the development of a hydrogen strategy is well underway and a top priority for the UK government. The strategy will bring together the UK hydrogen story, showcasing activity to date and setting out an action plan for decarbonisation and expansion in the 2020s. There'll be a focus on how to continue support for the scale up of low carbon hydrogen production and how to stimulate demand and capture economic benefits. We've also established a Hydrogen Advisory Council in July to inform the strategy development and formalise engagement with industry. It's absolutely vital that any strategy is evidence-based and works with both government and industry. And we're also exploring how the UK can capture the commercial opportunities of the global shift to low carbon. And we're in regular discussions with businesses about their investment plans for hydrogen projects. And finally, so I personally work on heat. And in the UK, heat is the single biggest contributor to UK's carbon emissions. And hydrogen is one potential key option for decarbonising heat, alongside other solutions, including heat pumps and heat networks. So to help determine the feasibility of using low carbon hydrogen as option for decarbonising heat, the government is supporting a range of research, development and testing projects. And we're working closely with industry stakeholders to ensure that the overall programme of work is comprehensive and provides the necessary evidence to assess key issues, including safety, feasibility, costs and benefits, and the overall consumer experience. The UK proudly hosts a range of hydrogen projects. A number of these are in the heat space. So these include High for Heat, which is a government-led programme to establish whether it's technically possible, safe and convenient to use hydrogen in residential and commercial buildings for heat purposes. And the H21 NIC project, which is an industry-led programme which is exploring the safety and feasibility of using hydrogen in Britain's existing natural gas distribution network. So as you can see, the government is excited about the potential for hydrogen to play a role in decarbonisation. And I look forward to hearing more from the other participants today about the exciting work they're doing in this space. So thank you, that's all from me.
Thank you, Emi. As you have noticed, it is important in the UK strategy to use a transition fuel, blue hydrogen with CO2 capture technology. Now I would like to hear from the Polish government. I invite Szymon Byliński from Climate Ministry to speak about the government approach to hydrogen. And I think, Szymon, about UK strategy, and please tell us about Polish roads. Hydrogen roads.
Yes, good afternoon. Hello, thank you for inviting me today for this panel. It is a pleasure to be speaking with you today. I think we have a very important moment when it comes to the hydrogen. Now we have a fourth or third hydrogen revolution, and we have seen a level of interest in the hydrogen today. Hydrogen can be used in many different sectors, give us numbers of opportunities. As it has been said, hydrogen can be used like natural gas to heat homes, industry, generate electricity. It can power fuel cell electric cars, trucks, buses, ships, trains. This is why hydrogen offers the solution to decarbonize the economy, and especially to help climate for the industrial process and economic sector, when reducing carbon emission is very, very hard to achieve. I mean, such as steel, chemical or petrochemical sector. When it comes to the Polish plan for the hydrogen economy, we are working on our Polish hydrogen strategy. I believe that then in the next few days we'll be able to share some of parts of our strategy to the public. Our ambition, the ambition of government of Poland, is to develop strong national and local competences in the production of key components of hydrogen technology value chain. in the strategy, we would like to define our goals and measures necessary to introduce the hydrogen economy. We want to support energy transition in three areas: energy, transport, and industry. We are also addressing hydrogen production and distribution and the need to create a stable regulatory framework for the future market. The priority areas refer to the concept of sector coupling. For us, the use of hydrogen will help achieve not only climate neutrality, but also maintain the competitiveness of Polish economy by, I hope, becoming a technology supplier. We have a huge scientific and research potential in hydrogen technologies and fuel cells in Poland. We have great achievement in designing functional materials for production of fuel cells and hydrogen storage. In order to create the entire value chain and infrastructure, we need to design a comprehensive Polish research program with the aim to develop the technology and design of electrolysis and fuel cells. We are also start working on the regulatory side of the hydrogen market. We especially thinking about hydrogen on the regulatory framework of European Union. We also endeavor to create the best condition to invest in the hydrogen technologies. So our goal is to support the cooperation of the most important companies operating in Poland, which will enable the creation of innovative projects. But there is a lot to do in the hydrogen economy. Especially, it's very important to reduce the cost of renewable hydrogen production technologies, cost competitiveness of renewable hydrogen production in relation to its production from fossil fuels. But we also, for Poland, also is very important technological neutrality. We would like to focus on the emission of the CO2, but not on the color of the hydrogen. We are looking for the way of production of hydrogen, low emission way of production of hydrogen, because to achieve the goal set out in the European strategy, we should be open and use various possibilities of obtaining hydrogen. The key to selection of hydrogen production method, as I say, should be the level of CO2 emission from the production rather than the specific technology. And we believe and we are hoping that business and industry will carry the hydrogen technology through the commercial scale. The most important now is that governments provide swiftly and effective support which help the industry to develop the hydrogen technology in Poland. Thank you once again for inviting me. That's all from my side. Thank you very much.
Okay, thank you, Szymon. Stay with us. We would now like to offer the platform to a few UK companies to demonstrate their hydrogen capability. I'm asking you for short statements. I'm asking for the first one to speak. Mr. Dr. Cedric Rouaud, Global Technical Expert, Thermal System, Ricardo, UK. Cedric is floor is yours.
Thank you for your kind introduction. And I can see the slide now. Hopefully it's okay. Can you hear me well?
Yes, of course. Please, short. Okay.
Thank you. Yes, keep it short. So thanks for the opportunity in discussing in this forum. I'm very proud to be able to present our activities from Ricardo, UK, based in Shoreham by Sea. So just a quick overview of Ricardo. It's a more than 100 years company, and we have been developing different technology for propulsion activities, and now also focusing on the fuel cell activities. You can see a quick overview of the number of people, or turnover, and the different customers we can name in a public domain way. And also diversification. So that means that when we talk about hydrogen economy, it's not only for passenger car, commercial vehicles, but also for off-highway, train, aerospace, marine as well. What we do in Ricardo is we work on clean, efficient, integrated and digital propulsion and energy sector across different energy sectors, sorry. And we have different pillars where we develop the propulsion technologies. For example, on the electric one, we develop battery modules and battery packs, but also electric motor for electronics. We have also hydrogen, where we develop fuel cell system integration with balance of plant, and also hydrogen engine. So that means that instead of the combustion of diesel or gasoline, we have the combustion of gasoline directly in the internal combustion engine. Fossil fuels or renewable fuels also are a big part of our activities when we talk about clean and efficient internal combustion engines. That's part of our decarbonization and defossilization of the vehicles. And those powertrains goes into hybrid systems or directly on conventional driveline and transmission when we talk about renewable fuels, for example. Or on top of all of this, we have smart control, meaning that we have adaptive control, connectivity between the vehicle and the grid, the vehicle and the infrastructure, and the vehicle and the rest of the other vehicles surrounding the vehicles on the road. That is what we develop as the four pillars: clean, efficient, and integrated digital. In terms of fuel cell experience, we worked starting in the 90s, and we have continued across 2000 up to now with different activities on PM fuel cell or SOFC, and that means that we have had feasibility studies, support of demonstrators and demo trucks, for example, the ones we can name because we have a lot of confidential projects, but Toyota Portal Alpha and Beta have been presented in press releases with Toyota, so this is where we can name them. And then after moving on also closer to now, we have had activities on certifying the first demonstrator of hydrogen train in the UK. And that, of course, gives us the possibility to develop that for other countries. Aerospace is another one with electric vehicle takeoff and landing or electric aircraft. And we develop fuel cell integration for some companies here mentioned. When we talk about the fuel cell electric vehicle and the integration challenge, we have different challenges on the fuel cell stack, the balance of plant, but also electrifying all the components, the electric axle for commercial vehicle truck, development of electric motors, inverters to control those, and interact with the fuel cell through a DC-DC converter. So the packaging is key. And the thermal topic that is a big challenge because even if fuel cells are very efficient, all the inefficiency goes into cooling system. And this is why they might require even more cooling performance than a conventional diesel truck. The control will help to optimize as well as the hardware, the efficiency of the whole system, and potentially to improve it linked with the electronic horizon. So what will happen next on the road or on the railway or in the marine case. So we work on system modeling, simulation, system integration and control, fuel cell test activities, demonstrator, vehicle build and development. Those also four pillars of our activities in Ricardo. We don't have per se activities on the fuel cell stack, but we support fuel cell stack suppliers. On that, one important information is that the test of the fuel cell is something that we prepare to do for larger stacks. We can test stacks up to 100 kilowatt, but 400 kilowatt is the next test facility that we'll have in Ricardo, UK. And this is what is presented here. We have had already first provisional funding for this test facility for hydrogen fuel cell, but also hydrogen engine. And hopefully this is something, test facility that can be used and useful for Polish companies if they want to test. So the last case study is around the Toyota portal with different links. I wanted for you to have access to those to understand what we do in Ricardo when we talk about integration with the different attributes from the requirement, vehicle specification down to the prototype build. And you have an example in the background of our Ricardo US facilities. In this case, it was not in the Ricardo UK, but it's the same team operating, I would say, with the same knowledge. And we can have the same in Ricardo UK supporting activities, working with the Polish companies. So thank you very much for your time. And if you have any question at the end, I will be happy. But our vision is to be trusted global engineering service partner for clean, efficient, integrated propulsion and energy solution. Thank you.
Thank you, Ricardo. And now I invite Sam French, technical director from Johnson Matthey. Sam, we have already seen each other at our organization Hydrogen Workshop. Hello, Sam. And it's floor is yours. Please, 5 minutes for you. We don't hear you. Sorry, Sam. We still.
Can you hear me?
Yes, now it's perfect.
Okay, sorry. I want to talk this afternoon about low carbon hydrogen. Johnson Matthey's a UK-based company with about 15,000 people, just over 200 years old. As many of the presenters have said, key here is about routes to decarbonisation. Following up what Amy said, two of the real pillars in the UK are hydrogen, both green and blue hydrogen, but also carbon capture and storage. One of the key elements we see is that we need to be deploying these technologies in the 2020s at large scale so that we can learn and then have a real roadmap for large scale deployment in the following decades. As everyone's going to talk about here, hydrogen's a value chain. We need production, we need to be able to move the hydrogen around, and then also it's used in multiple applications, particularly those that are hard to decarbonize. An interesting thing about Johnson Matthey is that we're actually involved in multiple steps across this value chain. I'm going to focus on large-scale blue hydrogen production, but at the moment we're very active in large-scale electrolysis as well, looking at how we can produce components for green hydrogen. We've also had a fuel cell business for many years based in the UK, but now with investments globally, looking again at making the key components. Grey hydrogen was already mentioned. That's the route to making most hydrogen today, where you convert natural gas through steam methane reforming. Has about the same emissions combined as the UK and Indonesia, so a lot of emissions. There's a flow sheet involved. Steam methane reformer is the central block. The key issue with steam methane reforming is that you drive the reaction by burning natural gas. What this means is that you have a large amount of CO2 that you have to capture from the flue gas, from the waste gas streams. This is a really expensive process because it's a large volume of gas you have to deal with really low concentrations of CO2. What the issue there is then to be able to capture this, it requires high capital cost. So actually what we've found is that if you want to make blue hydrogen, there are better technologies for this. So what we've developed is a flow sheet. It looks fairly similar, but the key core component, this gas-heated reformer and autothermal reformer, the key difference is here we're adding oxygen into the system to drive the reaction. You could do this with just an autothermal reformer, but the combination with a gas-heated reformer means you use your energy much better rather than just generating steam. And this means that you can get a higher efficiency process. So we see this as a technology which is the highest efficiency for creating blue hydrogen with a lower capital cost than both a steam methane reformer or an autothermal reformer on its own. This means you lower the levelized cost of hydrogen. What we can see is due to the higher efficiency, we're using less natural gas per unit hydrogen. And the natural gas is the key component of the OPEX cost for the plant. But it also means we produce less CO2 per unit hydrogen, so we have less CO2 to store, which is also an additional cost. We've designed this flow sheet as well to utilize all of the process steam and be energy balanced. But then beyond that, we can import electricity from renewables to drive things like the air separation unit or compressors and pumps. This technology has been demonstrated. The picture on the right is a methanol plant in Australia, where we've installed a gas-heated reformer and autothermal reformer, and it's operated for many years. We also have installations in the ammonia market. So we've used our learnings from those other market areas to develop this flow sheet for hydrogen. We're targeting greater than 95% CO2 capture from the process. Johnson Matthey doesn't build plants or operate plants, but we provide the technology license and the basic engineering, the blueprint of the plant, as well as the key catalysts required in the process. We're currently working on a couple of UK projects that I can describe that have been sponsored by UK government to date. This project at Hynet is in the northwest of the UK near Liverpool and Manchester. It's a 300 megawatt lower heating value size plant in phase 1. This is currently in front-end engineering design. And with the business models that Amy mentioned earlier, this plant could be operational in 2024 or 2025. The CO2 from the plant is to go offshore into depleted oil and gas fields that Eni operate, and they were recently granted a carbon capture and storage license. The hydrogen's to be used on the SR Stanlow refinery, as well as in other industrial uses in the area, such as Pilkington Glass and Unilever. Some of the hydrogen will also be blended into the natural gas grid. The other project's up in the northeast of Scotland at St Fergus. This is where a lot of UK gas comes into the country. Again, this is located in a good place for access to carbon capture and storage. Key to the process really is that we can capture the CO2 in the most cost-effective manner. All of the technology options, particularly the CO2 removal, are well proven, driving down the capital cost, but really important when we're considering the large amounts of hydrogen that both the UK, Poland and other countries is about high efficiency. So we're ready to deploy this technology. We'd be more than willing to speak to anyone who's interested in a blue hydrogen project. And please get in contact with us via our website. And I'm more than happy to take questions later. Thank you.
Thank you, Sam. Now, please, Ben Todd, CEO from Arcola Energy. Ben, you are ready?
Yeah, I'm ready. Can you hear me okay?
Yes, it's perfect. Please, floor is yours, 5 minutes.
Perfect. So yeah, good afternoon, everybody. Very pleased to be speaking with you. So I'm Ben Todd, founder, CEO at Arcola Energy. I've been working in fuel cells now for about 20 years. So Arcola Energy is a leading UK specialist in hydrogen and fuel cell integration. Our focus is on zero-emission heavy-duty vehicles, buses, trucks, trains, and marine. We are a systems integrator and tier one supplier. So that means we provide engineering services. We also then provide tier one supply of equipment into OEMs. So a bus or a truck manufacturer can take our systems and integrate them into a vehicle. And in this early stage of the market, we work right across the whole value chain. So we think of it in 4 stages: a kind of market creation stage, product development engineering stage, a manufacture stage, and aftermarket support. And within manufacture, that can be the tier one supply. And in fact, in some of our contracts, we are, in fact, if you like, the prime contractor. So we will partner with an OEM to provide us with a chassis, and we will be the final authority on issuing the vehicle. So after 20 years in fuel cells, we work across high and low temperature, 1 watt to 1 megawatt, a very broad network globally in the hydrogen fuel cell industry. A very key focus for us is on quality, safety, and compliance. And this is how we've built our company on our reputation. We run 4 facilities in the UK at the moment, 2 in London, an engineering office where we started in Hackney, a new prototyping facility in Enfield, a manufacturing and vehicle assembly facility in Liverpool, and next year we will open a new facility up in Dundee in Scotland for the Scottish market. So over the past 10 years that Arcola Energy has existed, we've worked through a variety of vehicle types, starting from the kind of 2012, early stage small vehicles, lightweight, sub 850 kilograms, small fuel cells. 2014, we developed the world's first hydrogen double-deck bus. Unfortunately, that project didn't go through into commercialization and paused. We then spent quite a bit of work in stationary, working both with natural gas, with internal reforming, and on hydrogen, and came back in 2017 into automotive, which is our current focus. So looking at light commercial vehicles and then into heavier vehicles, so double-deck bus. We did an excavator, 20-ton excavator last year, this year, and a refuse collection vehicle is under development at the moment. So as an example of the hydrogen double-deck bus, it's an electric drivetrain, of course, so it gives you very much better acceleration than diesel, 40% more efficient than diesel on an energy basis, fast refueling. We have a very good hydrogen efficiency due to the optimization of the whole vehicle system. And this provides 180 to 240 miles of zero emission range, 300 kilometers, full zero emission. And we don't lose range in the winter. This obviously is a key distinction between battery and fuel cell, is that we can recover the heat from the fuel cell system. A key part of our success has been repair and maintenance. So we operate the largest fleet of fuel cell commercial vehicles in the UK. These at the moment are small vehicles, but it's allowed us to build up that expertise and knowledge of what it takes to train both the OEM, this is a Renault-based vehicle, and the depot technicians and managers, the drivers. And we have a network across the UK of approved maintenance contractors. Moving on to our platform then, so at the core of everything we do is a technology platform. It works across the whole fuel cell electric vehicle powertrain system. So from the driver controls, the pedals and the dashboard, through to the motor and the wheels. So hydrogen system, fuel cell system, battery system, high voltage, low voltage, and control. The way that we bring vehicles to market is using our proprietary powertrain platform. So this is a control system that sits at the heart, interfaces all of the different components of a fuel cell vehicle with fully parameterized for working with various different fuel cell systems, battery systems, motors, and ancillaries. And by using the same platform in multiple vehicles, of course, we can move more quickly and more cost effectively. So we're able now to bring a new hydrogen fuel cell vehicle to market in 1 year. So from diesel to fuel cell in 1 year. So a little bit more on that. In the grey box in the center then is our kind of proprietary platform. And around that is then the engineering skills that allow you to bring a vehicle to market. So deep understanding of the user requirements, so modeling, simulation, capturing requirements from the users, obviously regulations, codes and standards, and then into the physical vehicle integration and functional safety. A quick note on our approach to fuel cell electric vehicles. So we believe that batteries and fuel cells are both brilliant. This is not a VHS Betamax competition. This is petrol diesel. Batteries are good for some applications. Fuel cells are good for other applications. But we think you should optimize properly in both cases. So taking a battery vehicle, adding a fuel cell range extender does not give you a good fuel cell vehicle. It gives you a suboptimal mix in between. So we believe in fully optimizing. In terms of a few words on our market approach. So our approach, obviously, clearly we need vehicles. We, of course, as has been touched on by the early speakers, we need fuel, we need fleet support, and we need a financial model. And so this is this integrated, I suppose, vertically integrated business model, you could say, that we've developed, where we can define and understand the requirements for vehicle. We can develop and produce the vehicles. We work then very closely with fueling partners to provide fuel at the right cost in the right place, the fleet support, and then working with government agencies and financial institutions to give the customer proposition, which will allow us to deliver vehicles. So how we develop projects. So we think of it in two ways. There is a top-down, fuel-led approach. Where can we access low-cost fuel? This may be existing brown or blue hydrogen. It could be new green hydrogen coming on stream. And the other approach is bottom-up. Where are there fleets, fleet managers, local authorities, vehicle users who want to make something happen? And we can try to join those two things together. And this is the way in which we operate. So our current activities, then, we continue our work on off-road machines. So from the kind of 20-ton up to 400-ton. So for construction and mining, we have 3 programs running at the moment in rail. So this is looking at regional and suburban applications. Buses was an early market for us, initially in double deck. We're branching out now into single deck and coach. And trucks is the most recent market we've moved into, with our first vehicle on the road next year. This is in develop currently, and contracts for a further 20 to follow on from then. Once the refuse collection, so this is bin lorries, garbage trucks, is moving, we start now to look at urban distribution. And so our approach in all of this is to find the right partners, be that supplying as a tier 1 into an OEM, or indeed if the OEMs are not ready yet, we are very happy to buy a chassis, create the vehicle and deploy the vehicle fully homologated under an Arcola badge. So final question really, how can we work with you? I think I've said enough about what we do. Really our interest now is finding the right partners. So whether that is deploying projects in Poland or it's working with Polish OEMs, Polish technology providers, we're interested in, who has complementary capabilities and requirements, and how can we work together? Thank you very much.
Thank you, Ben. And finally, before the discussion, please give me a short presentation. Julian Parker, CTO, Titan Electricity. Julian, floor is yours. Do you hear me? Hello, Julian Parker. Sorry, Julian Parker is out. So thank you all for interesting presentation. Please join us now for the roundtable discussion. Julian is here. Okay. We don't hear you, Julian. Please. Julian, sorry, we don't hear you. Try again, Julian, because we don't hear you. Maybe you start mute, please. Julian? Sorry, we don't hear you. Julian, we don't hear you. Okay. Julian, we will start a discussion, and you will solve the problem with the voice, okay? Okay. We don't hear you, sorry. Julian, okay. We will start the discussion, well, and I'm asking you to help Julian, please support, okay? Thank you all for interesting presentation. Please join us now to the discussion. Before we start the discussion, let me summarize briefly. We have heard from a representative of the British government that the decarbonization using hydrogen is to use the potential of the energy sources and already existing technologies to reduce emissions. Of course, the target direction is the use of renewable hydrogen, although the Polish government, above all, the create a real hydrogen market, will want to use the potential we have in the production of hydrogen. Short point to make. Gas decarbonization will take many forms, and that picking a winning technology is not the way forward, but rather innovating with a technology natural approach. This can biomethane, blue and green hydrogen. Now I start to moderate the discussion, asking a question to speakers. First question for companies PKN Orlen, Jacek Smyczyński, listed to the government's view and to UK business. So many first questions goes to the representatives of companies PKN Orlen and LOTOS. Jacek, Orlen has just published tender for a hydrogen hub. What were the key business drivers behind this decision?
Well, thank you. Can you hear me?
Yes, it's perfect. Jacek, shortly, please.
So, as you know, Orlen in September this year announced the Green Deal for 2050 as a company. So that's a great challenge for us. And I'm pretty sure that finally the key will be hydrogen. As the biggest fuel supplier in this region of Europe, we decided to clearly say that. First, we understand there is no way back from energy transformation we observe in Europe and the rest of the world, at least the richer one. Second, we still want to be a leader on the fuel market now and within the next 20, 30, 40 years. And the third, launching this, what I always call energy wind of changes, by introduction of a new zero-emission fuel to public transport, it would be a really good starting point for Orlen, mainly due to a chance to show relatively quick results, which can be observed and can be felt by common people living in cities. There is no big deal to be first at the Polish market with brand new hydrogen station. That's a question of purchase it. But if you want to be treated as a serious partner, you need to do much more. I mean, find and produce hydrogen with adequate quality. So that's why we are talking about hubs. Compress it, storage, distribute, and finally deliver it to client. Moreover, you need to do this in responsible and reliable way without any breaks in delivery, always with good confirmed quality, always on time, and so on and so on. The challenge is that in Poland such system doesn't exist yet, so we need to build it up from very beginning. And the truth is that we need to learn how to do this. So we decided that first we focus on hydrogen system dedicated to public transport, as I believe most wanted at this moment. But of course, it would be a possibility to fuel with hydrogen also cars. Introducing hydrogen fuel in dozens of cities in Poland, we believe that we create some kind of hydrogen network, which then can be fill up with hydrogen station settings between cities, but of course located at our existing gas stations, everything to complete the hydrogen system. And that way we give a chance driving across our country using hydrogen. It's worth mentioning that in the same time we observe huge potential in public railway transports. That's why we got a close cooperation with PESA, for example, one of our Polish train producers. Our goal is to create a prototype of siding locomotive as a first step, and then construct a public train. So this is our targets for this decade. For all this, we need hydrogen hubs. So I hope I answered your question why we focus on hubs. Thank you.
Thank you, Jacek. Now, second question for another Polish energy company, LOTOS Group. Emilia Berska is head of the innovation fundraising of this in LOTOS company. Emilia, please you now outline LOTOS hydrogen project.
Hello, good afternoon. I'm Emilia Berska. I represent Grupa LOTOS. Thank you very much for the invitation. I think it's a great opportunity to exchange our experience and knowledge about what we are working on and what we can offer. Our companies can offer. As Grupa LOTOS, we are engaged in many alternative fuels initiatives. One of our key projects consider hydrogen is Pure H2. The main purpose of this project is to deliver 5.0 hydrogen. By 5.0 I mean the purity of 99.999% of the purity. And in the scope of that's why in the scope of this project we have first of all construction of the hydrogen purification unit, which will be enabled to produce 160 kilograms of hydrogen per hour. And also we want to construct the distribution station in our refinery in Gdańsk and two refueling station, one along the TNT corridor, one of them also in Gdańsk, and the second one in Warsaw. The refueling station will ensure the pressure of 350 and 700 bars for the hydrogen to be able to refuel hydrogen buses and vehicles, of course. In this project, we also want to buy 2 tube trailers to ensure the distribution of this fuel to our refueling station, and of course other clients as municipality or public transportation. Right now, our tenders are in progress. Tenders for the key project installation. I mean, by key installation, I mean this hydrogen purification unit, distribution station in Gdańsk, and 2 hydrogen refueling station in Gdańsk and Warsaw. Despite this Pure H2 project, we also have other initiatives under analysis in LOTOS. They consider mainly the hydrogen production by water or steam electrolysis processes. And hope, as I said, we still analyze those projects, and hope we'll be able to say more about them in the nearest future. Thank you.
I'd like to add that you are in Czerny place. Okay. One question for Julian. Julian, we will try to show your presentation after the discussion. Okay. Sorry, we still don't hear you. Now, please.
Can you hear me yet?
Yes.
Yes, finally.
Yes, it's good. Now it's good.
Okay, excellent. I had to come back into the software. It wouldn't let me turn the microphone on. It was just it just locked me out completely. So
okay.
Bit hard to without having presented what we actually do.
Not now, Julian. After discussion. Okay.
I know this. I'm just saying it's. I can't really reference what we're doing. But basically, as a company, we are interested in investing into Poland because of you're very interested within hydrogen yourselves. We can help with hydrogen, cleaning up hydrogen production. And Poland is an attractive place because of that. I'm sorry, just need to just reference exactly what the whole situation earlier on has thrown me slightly. As a tech company, we can invest our technology into Poland. We can help clean up the production of hydrogen. You are, like the UK, are trying to advance hydrogen economy quite significantly in a short time space, not quite the same in some parts of the world, and it's encouraging to see. We can produce net zero energy, which can be used to sequester CO2. And you have a lot of engineers in Poland that high-end engineering, a lot of high-quality manufacturing. And basically, the whole market is attractive because of that. I really, so I'm a bit thrown from before. I really was going to reference my slides and at the short talk I was allowed to give if it hadn't zoned out the way it did. If you could maybe pass on to another speaker, please.
Okay.
Thanks.
Now,
oh. Are we going to, am I basically allowed to present then? Is that?
Yes, yes.
Okay. I don't want to disrupt everybody's flow though, really. But basically, okay, hi, my name is Julian Parker. I'm the co-founder of Titan Electricity, and we're a Northwest-based tech startup. We started about 5 years ago looking at whether or not energy can be extracted from the oil and gas industry's exploitation of methane. We spent a year and a bit researching with Lloyd's Register under a Innovate UK funded program called Energy Catalyst. And the culmination of this research work was that yes, we can extract large amounts of energy during the production of high pressure, high temperature gas. Now, one of the things about blue hydrogen is that the loop needs to be as close as possible for blue hydrogen to be truly clean hydrogen. If you're using a methane source for your hydrogen, then you really need to understand that the source itself has put as much effort into reducing the hydrogen, the carbon dioxide emissions source as possible. I'm going to go on to the first slide, which is basically an overview of the process from well to final blue hydrogen. So we start off with a natural gas well, and during the production of the methane, there is a CO2 footprint associated with that. Then we go into methane refining, where we're removing contaminants such as hydrogen sulfide, carbon dioxide, brines, and anything else that we don't want for pure methane. And then we have a process of methane liquefaction, where the methane is compressed down into LNG. Once again, we've got a CO2 footprint associated with that from the energy required in the process. And then finally, we can move our LNG or pipeline gas to a blue hydrogen generation point, where the hydrogen is generated, ideally using either hydrogen itself or a process where you are using methane but capturing your exhaust gases. And finally, the CO2 is taken and sequestered down. So if we're looking at this process, we all want blue hydrogen to be as clean as possible, but we do need to address the CO2 that's at the beginning of the process. And this CO2 may not even be in the same country. It could be in the Middle East. It could be in your neighboring country if you're in Europe. So next slide. basically, we have developed a technology that can produce large amounts of net zero electricity, basically by utilizing the high pressure and high temperature nature of some natural gas. We can get about 8 megawatts of energy per 100 million cubic meters of gas per day. And we can have, fields can have several, maybe even dozens of geo engines running on them simultaneously. And this electricity then is available for the methane producer to not use grid electricity, not use diesel electricity, not burn their own methane to power the whole process. And we cut out the CO2 emission. So the methane is then refined, and CO2 is, if it's being extracted out of it, and quite a lot of natural gas does have CO2 in it naturally, especially the high pressure and high temperature gases. This can be sequestered downhole, and we can use electricity then to compress the methane into LNG. And with LNG, we can then transport it onwards to blue hydrogen generation sites, where once again, the CO2 is sequestered and the CO2 is stored. This transportation is, we can't clean up the transportation stages. We're not going to be building wind-powered sailing LNG tankers anytime soon, but most of the system now is clean. And we can take it one step further. If we've got high pressure, high temperature gas, and we don't need to run methane refining because it's clean gas already, a sweet gas, we can then take it to the next stage. And this next stage is we can produce methane. We can carry on methane refining and CO2 if we need to, but we can use a geo engine to produce green hydrogen on site. With each engine developing 8 megawatts of power constantly, we have a life expectancy of 20 years. It's 20 years of continuous 8 megawatts power production, unlike other renewable sources. This isn't a renewable source, but it's a very long-term clean power source. We can produce 1,700 tons per annum from each machine. And as I said before, each machine may have 20 or 30 other machines running in the same vicinity. So quite a significant amount of hydrogen generation. And the cost is quite low as well, because you've got the capex for the geo engine itself over 20 years. And we really think we can bring it in around about 50 cents per kilo. As I say, with quite significant generation per machine. And that then feeds into the green hydrogen economy. Whether or not there is the high pressure, high temperature gases in Poland that are required is unknown. But you are working quite closely with partner countries to supply your LNG. And the ability to clean up at source is an important aspect of that. So that's the end of it. Thank you very much for letting me talk eventually. And I'm sorry about any problems we had earlier on, but we're Titan Electricity. This is my personal email address, and I'm happy to talk to anybody who wants to talk to us at Titan Electricity. Thank you for letting me present in the end.
Thank you, Julian. Now we go back to the discussion. Now question to Esperis. Łukasz, in your presentation, you touched a bit on international collaboration, saying that alliances with foraging producers will be necessary. What do you think foraging investors could bring to the Polish market?
Okay, thank you for your question. I hope you can hear me.
Yes, it's okay.
I will present the big picture of cooperation. There are at least 4 fields I can imagine. The first one might be surprising, but we need a sector deal, including UK companies in the offshore wind sector. Cheap electricity means cheap green hydrogen, otherwise it will not work. The same probably will be with CCS installation. I mean, if you want to produce the blue hydrogen, we need to cooperate with companies from abroad, like from UK, and because we are not, I think, advanced to speed up with this technology. The second field is green hydrogen, as we can develop here in Poland definitely electrolyzers, but on the small scale, if we're talking about the speed. And in case of large-scale electrolyzers, we should cooperate with the foreign advanced companies. And I can imagine that after merger of Orlen, LOTOS, and Peganik, the huge order might be placed on the market with offset agreement. I mean, part of the value chain should be located in Poland. So definitely it would be very important strategic deal. In case of public transport anyway, like trains and buses, we have factories here in Poland which may produce it, but they will need the fuel cells. And the question is whether we want to develop here in Poland fuel cells or import and use equipment from abroad, which might also be combined with relocated some parts of the value chain, because, well, the companies need in near proximity the supplier of equipment. Maybe it's not so obvious, but from the government perspective, if we want to speed up hydrogen progress, we want to increase the demand. And there are plenty of subsidiaries at manufacturers here in Poland, data center, logistics centers, controlled by the foreign companies, and we can encourage them to test initial pilot project concerning hydrogen, like replacing diesel generator for a hydrogen, or forklifts, or any other equipment off-grid, off-road equipment with used hydrogen. Here in Poland, I forget to mention that the same is with the chemical and steel industry, and we're only talking about the hydrogen itself, but also about ammonia and methanol. And I know some discussions are already with subsidiaries here in Poland. Maybe they can combine the cooperation with Polish chemical sector to decrease the risk and capex. But I see the major cooperation supported by the government. And the fourth field is definitely the research and startup industry here in Poland. So except for funds, which might be provided by maybe UK funds, public or private funds, we have to think much wider than only collaboration of universities, because here in Poland we have a capacity, I think, to develop dedicated for a hydrogen value chain smaller parts of the equipment, like rectifiers for electrolyzers, manifolds, racks, measuring station, purification station, low-cost methanol production technologies, and so on and so else. The IT industry in Poland is definitely well developed, and I think about the smart grid solutions. So Europe is supporting research collaboration, and we should really focus on this, and not only in case of huge installation like electrolysis and so and such. Okay, so that's my big picture idea.
Thank you. Now, please, I would like to come back to our UK speakers with the similar question. Could you each of you answer the following two questions? What could a foreign investor bring to the Polish hydrogen market? Could you tell us about reasons for attractiveness of the Polish hydrogen market? First, Julian Parker.
Hi. Have we got sound? Yeah, excellent. Consistency at last. Basically, we find the hydrogen market in Poland attractive simply because you have lots of land-based supply into your networks. So if you're making blue hydrogen from LNG or piped gas, a lot of it is land-based, which is a lot simpler way to deploy our technology early on. Rigs are not super compatible with the scale of the engines. So although we can work in UK waters, a simple rollout across land-based European locations where you've got high pressure, high temperature gas is very attractive to us. It offers the ability to clean up the LNG supply at the beginning of the process. So as per my slides earlier on, you've got a reduced carbon footprint from beginning to end. It's no use really taking pure methane from any supplier indiscriminately without understanding how it came to be, where it came from, and whether there was any significant CO2 emissions associated with that gas, which can in some places be quite significant because CO2 is entrained within the gas itself due to its burial. The two things go hand in hand. Depth of the reservoir adds to the CO2 level. So it's important when you're trying to close the loop to understand exactly where your gas is coming from. And you've got very high aspirations. You haven't got as much gas as you used to have. You've been using it quite steadily since the 50s. So your source is becoming more and more important. It's the same for the UK. We also are bringing in a lot of LNG, and understanding where that LNG comes from is it's important. It's the full traceability. We want traceability in our food. We want traceability in most things that we do nowadays, and we should have traceability in our hydrogen. And the hydrogen, you're ambitious in what you're trying to do. The same as us, we're based in Merseyside, which is one of the hydrogen clusters in the UK. We've got 8 such locations, as Sam mentioned earlier on. And the focus is very much about hydrogen. We hope we're going to be powered by hydrogen ourselves eventually. But the Polish market is, if you're prepared to embrace change and prepared to accept where we all have to go in the world, that's the important thing. And the fact that this exists as a forum shows that Poland's got the right attitude, and Poland wants to embrace new technology and move forward. And that's really where we see the investment coming from. If you want businesses to push their products and their ideas and staff and personnel into Poland to help clean up the entire production of hydrogen, I think that's where we come from.
Okay, yeah. Thank you, Julian. Now, please shortly answer on these questions some French.
Hi, can you hear me?
Yes, it's perfect.
Brilliant. Okay, just checking. So part of the reason is that these projects, blue hydrogen, but in general, the hydrogen economy is going to require a large amount of investment. There's no one company who are going to be able to do it on their own. I think foreign investors will come if there's a business model and market that's attractive. That's part of what we're looking at the moment. This can't be, the energy transition is going to be managed, and we've got to make sure that the costs are shared and there is a just transition. But if you can put in place an attractive market, then private investment will follow. I think Łukasz showed a table earlier, which was the amount of gas that's used currently. That's going to be, that's one of the key things that you look for, is how you transition away from natural gas, with hydrogen being one of the most obvious places to go. And if you've got the infrastructure in place to deal with natural gas, in principle, it's not a big stretch to be able to use hydrogen. From Johnson & Matthey's perspective, we've got multiple sites in Poland, and we've recently invested hundreds of millions of euros in a new battery material facility in Poland. if you can set up the right conditions, people will come. And as I think was previously mentioned, there are multiple points down the value chain. So it's not about anyone doing it all. It's about doing a piece that is sensible and potentially then exporting that. So I think, you know, the countries that will gain most traction are the ones that can put a good strategy in place that's got a long-term strategy, so that companies can feel the reassurance with risks mitigated that things aren't going to change, and put in the business models in place that allow a sensible return on investment.
Okay, thank you, Sam. Cedric, please. Cedric, do you hear me? Hello, Cedric. Cedric, do you hear me?
Hello.
Okay. It's a problem. Cedric, do you hear me? Last moment. Okay. We also have a question from listeners. We don't have time to answer. We will send them by email to the speakers. We must end the discussion. Briefly, please answer the questions, 1 minute, the last questions for Polish company. First question for PKN Orlen. We have here an interesting view on international collaboration and the added value foreign investor can offer. But I know Orlen is also collaborating with local communities. Jacek, could you please explain to us why Orlen is so active with signing the letters of intent with local government authorized? Please, 1 minute. Jacek Smyczyński. Nie słyszymy cię, Jacek.
Momencik.
Yes, it's perfect.
Okay. So we are trying to analyze or even create hydrogen demand on Polish market in public transport area. So we talk with local authorities to try explain more about present and future benefits of hydrogen solutions. Show them that behind the brand of Orlen is certainty, reliability, mitigation of risk at this new hydrogen market. To succeed, we need to find balance, demand and supply of automotive hydrogen, and for that, two sides must be involved: supplier and client. So that's why we signed the letters of intent to give local governments some kind of insurance that getting into this business is not a short-term activity, but long-term cooperation. And on the other hand, for us is very important information about their attitude to hydrogen, to future transport, etc., etc. From conversation with local governments, we know the uncertainty, the hesitation to be involved in new technologies, but also the understanding of with present environmental situation. They feel the pressure of local societies to reduce air pollution, and such strong and reliable partner as Orlen is helps them very much to make a good decision and engage in this still not yet mature hydrogen business. So that is our approach.
Okay, thank you, Jacek. Thank you, Jacek. My final question to Emilia. From what we have today, do you see any potential for collaboration with UK supply chain in hydrogen technologies, innovation, R&D, etc.
As I mentioned before, in Grupa LOTOS, we have already ongoing hydrogen project, and we also consider new initiatives, especially concerning the hydrogen production. And I believe that using our experience, exchange information as we do today about needs, plans, and possibilities, we can find many areas for international cooperation, because as was mentioned a few times during this conference, the goal is very ambitious to achieve climate neutrality. So we can say that that creates opportunities for many actions.
Okay, thank you, Emilia. Now, Cedric is the last chance to speak. We see you, but we don't hear you. Try again. I give you my vote. How you lead their problems with the voice. We finished discussion. Okay, Cedric. Sorry, this is a problem. Now, thank you to everyone for participation to the discussion, and see you soon in the next talks about the hydrogen economy. As you have heard, the key to the decarbonizing economy is the use of green hydrogen and the use of the intermediate fuel in the form of blue hydrogen. Sorry for a problem in the mute. Now we finish this discussion, and thank you for our speakers, and see you again to the next discussion about hydrogen economy. Thank you very much. Bye.
Thank you. Bye.